I'm giving a talk on C++ modules and implementing them in the GCC compiler. I changed the title of the talk because when I had G++ there, people said, is this another language to C++ or not? And I thought, okay, right, never mind. I've made that mistake before, so. And interesting use of modular shipping containers in Christchurch. So, yes, right, let's get on with, the last time I gave this talk was to a compiler conference and they were all compiler nerds, so we went right into the details of the implementation stuff. But that's not this audience, so I've modified the talk a bit and hopefully there won't be too much scary compiler stuff in and you'll get stuff out of this. So I'm going to talk a bit about what the module's specification says. Maybe you all know it, but it's good. And I'm just like the kid who's discovered that they've got different money in Canada and is telling everybody this exciting fact. But we should be all grounded in the same place, and then I'll get on to some of the bits inside the compiler, some interface choices and design decisions there that are going to impact users, and where I've got to. So, why modules? Why can't we just carry on using header files? We've used them for 40 years, from C, 30 years for C++, whatever, anyway. And nobody's complained before. Well, yeah, right. You know, header files have got much bigger than they used to be. You know, if I get a compiler bug to fix, I'm lucky if I've got 500,000 lines of pre-processed source code that is, you know, 10 lines of program and 500,000 lines of template stuff that's all in the header files and, you know, cut it down. But the point is that the compiler has to keep passing this stuff every time you include a header file in different translation units and different compilations. It's redoing the same work, and this takes time. And they're nested. So if you include some header file, it includes the header files that it wants, and you didn't know that, so suddenly you've imported some other interface that you didn't expect. And you know, so internal details of the libraries leak in the header files because that's what's in there, and users are curious and might not read the documentation and go, oh, there's this function I can call, I shall call it, because they've read the header file, and then the library has a problem reorganizing itself because suddenly some important user is using an internal of the library. So it'd be nice if we could stop them doing that. Library writers also have to protect themselves from unexpected argument-dependent lookup because they might have bits in their template machine where they don't want ADL to happen. And that's apparently an exciting thing for library writers. What have we got? Oh yeah, we have this thing called duck typing, where if you think about a header file, it's defining some class, and we include that in two different compilations. Those compilations are compiling different sources, but the spelling of the class is exactly the same, so it looks like a duck in both of them, so we declare it the same duck. But then, actually, this is a no diagnostic required kind of a thing, and headers sometimes cheat and sometimes don't actually declare exactly the same thing. So they're kind of different, but they sort of work probably. And so let's not do that. Let's have modules, and we'll have better encapsulation. So that a module can say, these are the things that you can use from me, and these are the only things you can use from me, and you can't see the other bits of me that are my internals. And better, you know, so we get better consistency with the class definition thing. If you're using a module that's defining a class, you end up actually slurping in the same bits that the compiler put out at some point, and so you've got the actual same thing, and it's guaranteed to be the same in both translation units and whatnot. And all that header parsing and template parsing in the header files takes a lot of time. C++ is not an LALR1 grammar. That's a compiler term for meaning I can just look at the next token and figure out what I need to do. C++ requires unbounded backtracking because some of the paths are complicated and you don't know until you get to the thing. Until you can get to the end of an expression and just go, oh, hang on, this isn't a declaration. And it was Lewis pointed this out in his talk earlier about recurring bugs that turn up in source code, and one of them is most vexing paths, and that's the horrible one in the grammar. Okay, right. So some syntax of what modules look like. You know, simple idea is that you import an interface, and somebody's written that interface that defines what the module is, and then the module author goes and provides implementation of that interface, and you don't see the implementation except through the interface bits. And here's an example. So this is some user of a module, and it's using importing foo. I want to use bits from foo module, and I want to use bits from the bar module, and then I can just call functions that are exported from these things that they've made visible. Now you'll notice I haven't said foo : some foo function. This name here is orthogonal to namespaces. So you still really want to put the stuff in some kind of sensible namespace, so you have that namespace isolation that you have now with good modern code. So that problem is still a thing that has to be addressed in your module. Okay, so how does this foo module make stuff visible? It's got an interface. All the interface file is a regular translation unit. It's a regular source file that produces an object file with bits in it and functions that can be called and whatnot, but it also declares exports. So here's an example, and this is using the newer syntax of saying it's the thing that exports, so it's the only place where you see export keyword happening. So I'm the foo module and I'm exporting stuff, and this is a function. See, it's a regular function. It's not an inline function that you'd see in a header file. If this was in a header file, I'd have had to say inline there or template instantiation or whatever. But I'm making it visible to importers of this module. They can see this function foo version, and it returns an int. Very exciting int. I've got an accumulator variable, and again here I haven't said extern int ACC. I've just gone, there's this variable, I'm initializing it to 0 in this interface file. So there's going to be some bits, but I haven't got export in front of it. So importers of this module will not see the accumulator. That's some kind of internal implementation detail that I'm going to use for myself, and not visible to users. Here's some other bits. I've got a function, non-exported function, so that's only visible to within the module, and I haven't got a definition of it here because I'm going to define it somewhere else. Export class, I'm going to export a whole class. I'm going to export a load of members of this. All those members will be visible to importers, but of course we've still got public and private and protected access specifiers, so whether they can actually use all those members is still the same. And some internal helper class, which is again not visible elsewhere. And I wrapped it all up in a namespace. Other modules may use the same namespace as foo. That won't be a problem unless they end up doing things that collide with in ways that I'll get onto. Okay, right. Implementation. So the implementation units of a module are regular translation units in the normal way. They just provide definitions of classes, functions and classes and variables and things that you need in a library in the way that we need them already. There may not be any other implementation units other than the interface itself. That will be a very simple module where the entire implementation is in the interface file. But probably there are going to be several of these things for any particular module. And here's an example. So going back to that example I just had, this is an implementation of foo, and it's providing the definition of this frob function. And you'll notice I haven't declared frob explicitly. I've just gone, there's a frob in this namespace, and that's the reason that works is because the module interface, the compiler's read stuff in from the interface to make these things, so it knows about the things I had in the interface in this translation unit. I can just use this accumulator, didn't have to declare it, because it was already declared in the interface, add something to it and return a value. Then another piece of the interface, different translation unit, just defines the frobber widget, the frobber member of the widget class, and calls the frob function, which is this function up here. And again, nothing that actually needed to be explicitly declared, because it was already declared once in the interface file. Yeah. So this is the bit where we can pretend to be spies and do vaguely defined import-export business. So modules, export, you can import other modules. So not only user code imports modules, but modules themselves can import another module, so you've got dependencies. And I'm reusing my name, so sue me. Import Baz. I'm going to import Baz and use that internally inside the implementation of the foo module. That import, the stuff that makes visible to me is not going to be visible to importers of foo because I haven't exported it. But if I stick the export keyword in front of a thing, it exports it. So now the bar module, clearly the design decision here was that users of foo would need a bar, so we re-export it. So when you import foo, you're implicitly importing bar. And you get this dependency graph. The graph can't have loops in it. And Alistair's got a question.
Is that exporting the dependency on bar, or is it exporting the contents of bar?
It's making the contents of bar visible. So the question, is this just naming a dependency, or actually but it's not. It's making the contents of bar visible to importers of foo. So they'll just say import bar, and then they'll immediately, as if they just said import, they'll say import foo and see the contents of bar, as if they themselves had said import bar directly. Yeah? And there's another question there.
So if foo wants to use bar, then there has to be another import bar?
No. The question was, if foo itself wants to use bar, does it have to say import bar, export import bar? No. Export import bar is implicitly the same as saying import bar, export import bar. And another thing about this is that if you import the same thing in multiple places, it only actually happens once, and visibility might change. But I could say import bar, import Baz further down here, and second Baz would have no effect. And I think there's another hand. No. Yeah. Okay.
I wanted to ask if this is the same strategy as if you have an include that includes something else.
Right.
Are we supposed to import what we use directly?
Right. Okay. This is, should you rely on should you implicitly rely on, if I want a foo and I get Baz this way, should I implicitly import Baz myself if I wanted it? Well, this is foo here is exported bar for a reason. It will have documented why. Yeah. So, but the problem that we get with header file pollution is that if in this the header file equivalent to this, but I'd have said hash import Baz and hash include Baz and hash include bar, and I've made the contents of Baz visible to everything that hash includes me, even though I didn't want to do that because I only needed Baz for my internals, and that's the problem this is kind of solving. Okay.
But I'm just trying to say what you said again. So if I have a box and I have a point, the box is public, but internally the box is represented
by 2 points.
Exactly. But now what I'm saying is I don't want people to make their own points. I want them to make a box, but not points.
Right.
So in that case, I would not export points.
Okay.
I would export box.
You would export the stuff, you'd export your box class, but you wouldn't re-export the thing that was defining your point. Or if you defined your point class in your interface, you would not export it. It would be like that helper class that I had. Of because you may have problems with people trying to create boxes out of not points, but that's not the point of the question, okay? Yeah. Right, so this dependency graph can't have loops in it, and I think that was about it for there. You can't end up building it. I will probably get onto that. I'm going to run out of time if we just stop for questions at this point. This is a bit that I did expand because at the compiler conference, I just did much less than that, and then talked about compilers, and then people came up and asked, and I ran a BOF, and they immediately asked them a few grounding questions. And being compiler writers, they went, yeah, what about this horrible corner case over here? What about this horrible corner case over here? So don't do that too much. All right, so this might answer the question that you were trying to raise there. So here's a picture of how things hold together, and this is going to start off with a header file version. We've got a library, it's got some source files, they get compiled into object files and turned into a library archive. We've got a user source that compiles into a user object and linked together, and you get an executable. But there's a bit missing from this picture, which is that bit. Okay? In addition to having the foo library sources, we've got this foo.h header, which we hash include here and we hash include there. And the compiler goes, oh, I've got to hash include something. It goes down a search path and finds it and then incorporates it during the compilation, and off we go. So this picture now changes with modules, is that rather than a foo header file, we have a foo interface file, which is just a regular source file. Get a foo object out of it, added it into the archive, and off you go there. But the point was we wanted to get rid of this header file, so let's go away. So how do all these bits here, this bit here and these bits here, know what was in here? We end up with this new thing called a binary module interface. So that's some artifact of this of compiling this interface. Not only do I get an object file, I now get this other artifact that's new, and that's incorporated into the compilations of the things that do the importing or the things that do the implementing. And now I've put it as a separate file here, right? Because that happens to be how I'm doing it. It's a implementation choice. It doesn't have to be a separate file. It could be, for instance, incorporated into the object file in some way. Or it could actually be another stage of the compilation. So at the moment, the compiler formally goes through, source code, pre-processed code, assembly code, object code, and compilers may oblige various cases in that. And this can't be another step in that compilation process that is a new one. But that doesn't change the concept that's going on here. And there was a question. Okay, right. Question about parallel build stuff. I'm going to get to that. You've seen an issue there. Yay, you. Okay, so now I'm going to dive into compiler stuff. And, if you don't like compilers, tune out now, or don't want to know. If you want to know what's going on inside the compilers, then this is the bit. So GCC. GCC used to be called, GCC used to be GNU C Compiler, but now it's the GNU Compiler Collection because there are more than one language. So GCC is an overloaded term. GCC is the thing you type if you want to compile C code, and G++ is the thing you type if you want to compile C++ code. And the difference is library selection. Anyway, yeah, so it's open source software. You can go and download it, build it yourself, play with it, whatever. Most people don't do that because building compilers is hard, and just use the one they're given. Whole bunch of different developers, and generally specializing in different areas of the compiler. I happen to specialize in the C++ front end because that's what I've been doing for 20 years or so. And, oh right, development versions. So there's a source tree somewhere in a version control system, and the numbering scheme we have now converged on is that the development trunk is called version n.0 for some n, and at the moment n is 8. So 8.0 is the development trunk. it's changed at 4.9, because at 4.9 we thought, what's the next version? Is it going to be 4.10 or is it going to be 5.0? And if it's not 5.0, when is it ever going to be 5.0? So we just decided to just move all the version numbering on, move the point down one place. And so after 4.9 you got 5.1, and then no user had to use a 0.0 version, and everybody was happy. And it's unambiguous now whether it was the development version with a 0.0 or a release version. Generally aim for stable releases every spring. So around December time, things start getting slushy and freezing, and new features can't really get in between the team during that stabilization time. And the version in spring will be 8.1 next spring. Okay. And then I think the current version is like at 7.2 or 0.3, a few point releases after, because bugs happen. Anyway, so feature development, small features will go directly on trunk. For instance, some C++ 20 features are going in, like Jakob just committed the bit field initializer thing that happened. And we found a bug in the parser that it wasn't being strictly correct, and nobody had ever noticed. Anyway, so this stuff is much more complicated than a small feature. It's going to take a while to do, so I'm doing it on a development branch. And it's in an SVN system because reasons. There you go. And there's a wiki page as well, which I update when I remember. So, things that change is namespace lookup changes. What you see when you look in a namespace is now different. You see the things that are declared in the current translation unit, but you also see the names that were exported by the things that you've imported, either directly or indirectly through the export-import syntax and stuff. And module implementations also see the stuff from their interface module that made available to the module. So, okay, stuff's got to change, and being a lazy person, I figured, well, what's the simplest way of getting this to work? And my idea was, inline namespaces. Contents of an inline namespace looks a bit like the containing, as if it is a member of the containing namespace. Maybe I can do something there. So you'd have something like this, where in my module linkage, I put them inside some unspellable namespace. Not very unspellable, but proof of concept. So that's that thing that's only visible within the module, the accumulator. And things that are exported, I'd have some slightly different namespace. And that's the thing that, I think this one wasn't, I've changed my example. Okay, this is now exported in this example. And it's sort of one level deep. And I ran this by the other C++ maintainer, and he said, yeah, that's not insane. So I thought, great, I'll do that. Now, inline namespace is clearly not going to give the entire functionality, because you're going to have to turn these on and off depending on what imports have been visible from where you're doing the lookup. So internal compiler magic will have to adjust the availability. Now, you see a plan that says, and then magic happens, you know how well it's going to turn out. It actually turned out surprisingly well, because and it allowed me to focus on the other big bit of stuff I had to get working before any of this worked. So it was a very useful stepping stone. Yeah, magic happens. Yeah, big cloud of doubt. So what I ended up having to do at this point was dive into the namespace lookup code in the compiler, which the compiler was originally a C compiler. Michael Tiemann cloned the source and then started hacking on it and turning it into a C++ compiler. And this happened incrementally as C++ was being developed. So originally they went in namespaces, and then there were like two namespaces, global and standard. And then there were more namespaces and stuff like that. So these got incremented over the last 20 years as new features added. And after this time, you end up in a very strange place. So I could either work around this strangeness and try and understand it, or I could spend the effort on actually making the strangeness go away, which is what I did. So, you know, that was full of n-squared algorithms, and n was, it started off small, now n's reasonably large, people use namespaces all over the place, for instance. And I was going to make n very big, so I was concerned. Anyway, all that stuff has gone away, and it's goodness in its own right. So that's actually on trunk and will be in 8.1. So lookup should be faster. I also did it with classes, because classes were objects that were quite convinced that member functions and member non-functions were completely different things and looked after them differently in a stupid way and had to look twice. And and that's in trunk. And the last patch on that I put in made something like a 3 or 4% parsing speed improvement and template instantiation improvement just for using, one binary search rather than 2 binary searches and that kind of stuff. So that's all niceness, and then I could start working on the module lookup, which I did. So internally in the compiler, we map the module names onto integers. So there's an array of these things, and we can put this integer in the declaration objects that are looking after your functions and stuff. And fortunately, I had some spare bits in the declarations to put this index, so I didn't have to make them the data objects in the compiler any bigger. Hooray! And per module, we have a bitmap of the things that this module imported, and another bitmap of the things that this bitmap is re-exporting. And when I'm doing lookup, I need to look at this imported map to know which symbols are visible in this namespace in this module. And this is the thing that when something imports this module, it gets this whole bitmap of stuff added into it. And for simplicity, modules import and export themselves. So names are bound to more than one thing. So in a namespace, there still ends up only being one namespace object, and the name there, it's got a hash table in it that maps onto the things that it's bound to. And in non-module stuff, that thing would be a type def or a class or an overload set or something like that. It'd be one thing effectively. But now names can be bound in more than one to different things in different modules. So we end up this hash map. This map gives you this sparse array, and the contents of the sparse array are for each module that actually binds it to something will have a slot in that array, and then this bitmap tells you which of those slots you start concatenating together. Right. So that's name lookup. Right, binary representation. Yeah. So interface unit produces this green box that I had in the other picture that's then slurped in by the importers and the module implementations. What is this thing? Well, it's not a redistributable artifact. There's no intent of binary module interfaces being things that people deliver to customers in the same way they might deliver object code or a library archive and a header file. The distribution mechanism is still going to be the source code of the interface units. And I'm locking, at the moment, it's got some version numbering information in it. I'm locking that to the modification of the source of the compiler because it's so unstable. And if it doesn't shout at me, I'm just going to get very confused at times when I've fed it a BMI that came out of a different build of the compiler. And I understand that Jonathan's doing a similar thing with his compiler for exactly the same reasons. Anyway, so what format should this be? Well, GCC's already got link time optimization. Link time optimization is when we compile the program into an internal representation and squirt that out to the disk, and then the linker concatenates all this stuff together and reinvokes the compiler and says, yeah, go nuts now, you've got the whole program. So that's reading and writing internal representation of the program. Maybe I can use that. No, life is not like that. The LTO is for optimization, and it's squirting out the low-level GIMP representation of the program, which is an SSA notation you don't need to know about, but it's a low-level thing that's good for optimization. and I need to squirt out effectively the high-level front-end representation of the program. So that code's useless to me. And for types, although the optimizers need to know about types, they only really care about ints and record layouts, and they don't care about anything else. Whereas I need to have the front-end representation of types with templateness and all that stuff, and visibility, accesses and public and private and whatnot. So that doesn't really work. So I had to write my own streamer for this. We stream out the abstract syntax tree. And I'm just using a very simple tag contents notation, handwritten parser. It's not using any of the garbage collection machinery or the PCH machinery in the compiler. We're not going there. And I implicitly number these nodes because this AST is an arbitrary graph. It's going to have loops in it and I need to know back references. So I implicitly number these as they stream them out, so I only have to do it in one pass. It's like Lisp pretty printing, but a one single pass thing. And then some of these tags are, if they're not in the range of numbers for back reference, then they're going to be an actual contents and have contents. And I have special markers for what the target is, so you don't mix versions of your compiler saying, squirt out a thing for an ARM target and then read it and try to compile x86, because that's not going to work. Bits of the ABI get embedded in this, because for instance, size T, and you may have 32 and 64-bit variants of your architecture. So you should think of this file actually as a caching artifact. That's what it really is. There's import tables and stuff. Cross-module references, so one module imports uses names in another module. I don't stream out the other module, I stream out the name of that thing and some context so that it can then do a lookup in the symbol table of the other module. There's some special cases for tag types. Inside a compiler you've got, for a class for instance, you'll have an object that represents the typeness of it and an object that represents the decalness of it, and they point to each other. And when you're passing a type hierarchy, you find the typey thing first, but the thing you want to look up is the decal-y thing because that has a name. So there's an ordering problem, and just have some special tags to mention that. Oh, and synthesized objects like type info objects. I don't stream out the type info object, I stream out a tag and the type, and it resynthesizes it on import. So, application binary interface. Oh, right, yeah. So now this is the bit that hits object files. And we had this new concept here of a name that's only visible within a module, and it's across translation units of the module. So this is a new kind of linkage, and this is the language level term, external linkage and module linkage. External linkage, we've always had that. That's like things that are implicitly extern or explicitly extern, i.e. not static. But this is a new thing. And, and module ownership is new. These two symbols are owned by the foo module. They have an ownership thing. So somehow we've got to map this onto object files so that linkers still work and that kind of stuff, or make linkers work. So I'm going to have some examples, some motivating examples now. Okay, so we've got module bar exports a bob, and for purposes of this picture, all bobs are the same. They're a void function, for instance, let's say. And some other module imports it and then uses bob. We've got some other module, Baz, and it too exports a bob, different bob, but the same name, identical same name, in the global namespace. And other module imports that and uses bob. And then we linked it all together. Should this work? If it was old world non-module stuff, this would not work because you get an ODR violation with multiple definitions of bob, and the linker would go bad, go away, have a think. And formally in the module specification, that is still true. These things have external linkage, and you've got a multiple definition error. It's a bit confusing because you think, well, these things here had no idea there was this bob thing back here, or the collator of this thing was unfortunately hit by an indirect dependency. But that's a problem we've already got. It's not a new problem with modules. Right. Next motivating example is this one. We've got a header file. And extern bob. It declares a bob, and somewhere it also provides an object file with a bob in it. I haven't shown that bit. Old code uses the header file and calls bob. And then the authors of this module, of this header file, decide, well, we'll go and turn it into modules now. Okay, so they convert this header file into module-ness, and the whole library into module-ness, and it exports bob. And new code imports that module and uses bob. And then we've now got we've got for some reason we're still using this library that uses the old way and our new way, and this new library that's using our new way, and we link it all together. Oh yes, and there's two cases here of interest. Either this is unrecompiled code that we can't touch. Should this end up being the same bob and not get a redefinition error or confusion there? And the other case is that the authors of this, when they modularized this thing, they provided a backwards compatibility header that you can recompile this code, and with a hash include though. And the backwards compatibility header didn't just say import bar. It actually declared it in a way that you could use an old compiler, a non-modular-aware compiler for. Do you want that to work? And we had to think. I talked to Jason and Gabby, and I can't remember if Richard was in the conversation at some point as well, probably was. This case has to work. This case we don't care about. It'd be nice if it worked or did something, but this case has to work, because otherwise you have to convert everything all at once, and that's never going to fly. So, right, okay, so this is just repeating. Module linkage is new. These are some symbols. I'm not going to assume any new magic linker technology. People are going to have to update their compilers and their build systems. If they think I'm going to have a new linker technology, they're going to go, oh, screw this is too hard. So we're going to stay with the linker technologies that you already have. And for this slide, I'm just going to say it's ELF, because that's easy. But it's not specific to this. And we're going to we want compiler independence at the object level. We want to be able to build our object files with different compilers and have them linked together, even if we end up having to rebuild the interfaces with a single compiler to be able to get the BMIs that we need. So how do we do this modular linkage? Well, it's going to be the only linkage level thing at ELF that we have is global symbols. Symbols can either be global and visible everywhere in the program, or they can just be visible in the current object file, i.e. static and local symbols. If you've heard of hidden visibility, that doesn't help here for this particular problem all the time. So name mangling, which is the scheme that we have already for saying if we've got multiple foo functions and an overload set, I have to distinguish them at the symbol level. And you may have seen these symbols if your linker was not demangling them for you. That's the scheme that we have. So here, I put spaces in them to make them visible, more readable, but it's all one underbar Z name and some stuff. So this is the current mangling for this exported function. And we're not changing that. So that means that bottom right corner that I showed you in the previous slide still works. So exported things have the same mangled name as they would have in a non-module world. But the module, the module linkage thing, we do change the name of, because other modules can declare their own foo fob function within them, and they would still have global binding at the ELF level, so they better be different names. And the scheme here is that we just stick a little bit of, we mangle the module name in before the nested name specifier of frob. So again, that's what it currently is, that's what it becomes. One thing that you may notice, that if I've got a random symbol that's exported, there's nothing in the symbol telling me the ownership of the module. So I don't know, if I've got two symbols that collide, there's nothing in their name, well, they collided, There's nothing there that's telling me, oh, you need to look at these two different modules. That would require new technology, effectively. But in the module local symbols, module symbols, they do have a name, some information in them, so you can see where they came from. Okay. Right. So what have we got now? Yes. Okay. So this binary, this is the question we got. Where does this binary module file come from? And good question. You know, how do we name it? We had obvious choices are from somewhere from the module name or somewhere from the source file of the interface. I've deliberately chosen a very stupid way of doing it and a big fix me, so that nobody believes what I've put there is sane. That might blow up in my face, I don't know, but that is what it is. Where do we find it? Do we use some kind of search path mechanism in the same way as a header search path? Dunno. And clearly there's going to have some kind of build system integration because there's this dependency. With header files, if I've got a clean build, I know I have to build the object file anyway. So during the build of the object file, I can find the header. I can note the header files I read and I now depend on these header files. And so the next time round, I can go and figure out if something changed and I have to rebuild. But that doesn't work with module because as soon as I see the import, I need that BMI there, and it's too late if I haven't already built it. So there has to be some way of integrating the compiler with the build system, but it has to be done in a way that you can on the command line still say, oh, compile hello module hello world, compile main link works. If people have to have a massive build system integration to just compile the simple toy examples, people are going to be upset. So I suspect some kind of hook in the compiler that has default behavior that works for the simple cases and can go and query the build system if the build system hasn't set stuff up properly. Ideally, you'd like the build system to know this information up front, but that requires it to essentially parse all the code and figure out this stuff, whereas in fact the compiler figures it out while it's compiling, but there's no direct connection back to the build system. And then you have the distributed build problem on top of that. So that's going to require experimentation and thoughts, but you can't really do much there until you've actually got some kind of module compiler to actually play with. So I expect these more answers to turn up. Okay, so where I got to, and this is valid for a few. So name mangling, that works. And yeah, so I've been working with Richard Smith of Google, who I thought, yeah, there he is, to figure out this name mangling stuff so we agree. And there's actually a standard for it. It's on a GitHub repo that it's part of the Itanium vendor neutral ABI thing that got mentioned earlier today in the exceptions talk. It's part of that. Obviously, we'll be suggesting this as an extension when we've figured all the bits out. Import and re-export, I can do that. I can import modules and I can re-export modules. Free functions, they work. I can have a free function in the interface file and users can call it. I can have an inline free function in the header in the interface file and importers will call it and it'll get inlined. Classes, I can do classes to some extent. I can have fields, I can have member functions, I can have virtual member functions, I can have some inheritance. The value of 2 exotic might be quite low for most users. This is by no means usable in anger. It's just, yeah, it's alive, but it's like only just. So here's my to-do list of stuff. I'll take audience requests now as next feature. Yeah, we have a winner. Ding, ding. Templates. That is next on my to-do list.
Clear your desk.
Sorry?
Clear your desk. It'll take a while.
Yeah, I suspect this will be some templates, not all the templatedness all in one go. But yeah, that's the next thing on the list. I haven't done all the abstract syntax tree nodes. For instance, I've just realized earlier with an example that all floating point constants are 0. Variables, I don't do those at the moment. I can do virtual vtables, which are like a variable, but special. More class stuff like different members, type decals in a class, can't do it, that kind of stuff. I haven't done anything with enumerations at the moment. Inline using directives, I punt on those. They're just global at the moment, so using directive anywhere affects every single module all at once, which is clearly wrong. Using declarations, don't do that. I asked some questions in Toronto about using directives and declarations, and the answer was, "Ooh, good question. What do you think it should do?" So I wrote down what I think it should do. and I'm sure we'll be having more meetings on formalizing that. Anonymous namespaces. There's one anonymous namespace throughout the whole compilation, which is clearly wrong. That should be isolated in the way that it currently is. I haven't talked about the global module at all. That's a kind of a thing for transitioning old code to new code. I've punted on that at the moment. Location information. When you import a module, all the decals in that module that you become visible, their location is the import statement. So yeah, debugging is going to be horrible. But you can't write sufficiently complicated programs to need a debugger at the moment. So, linkage promotion is an exciting thing that Richard spotted to do with if you've got an inline function in an interface unit that refers to something that's static and only visible in the interface unit, you suddenly have to know that static thing has to be visible everywhere else because you might want to inline that function or instantiate that template through somewhere else in some other object file. Error checking. Obviously there is some error checking there, but users are very imaginative, and I'm sure there are cases I've forgotten because why would you write that? ABI flags, yeah, okay. I did say there were tags for ABI flags. They're not filled in at the moment. I only have one compiler. Search mechanism, thing for the BMI stuff, I haven't done anything there. So, it's kind of got to get into C++ 20. So, but big to-do list. So, next question is, when's it all going to be ready? Well, predictions are hard, particularly when they're about the future. So I will make this prediction that it's not GCC 8. As I said earlier, if you're paying attention, GCC freeze for release around December time for a release in spring, and that gives me 2 months to do that to-do list. Yeah, that's not going to happen. So not GCC 8, go and admire Bryce Canyon because it's beautiful. Okay, yes. Questions?
So you mentioned you can inline cross-module boundaries.
Yes.
How does this have to take the function implementation into the binary?
Right, yeah. So inline, it was about a question about inlining across module boundaries. You have to effectively do this for the case to think. I'm using inlining as an example, but the actual driving case is template bodies. You have to instantiate the template, you have to have the template body, and that's why they're in header files at the moment. You have the same problem. And the answer is the same, that in the binary module interface file, that actually has the body of the inline function. It doesn't have the body of functions that are not inline but defined in the interface file, in my case, because it doesn't need it. Other compilers may differ. But in GCC case, it doesn't. And then if you want that inlined across compilation units, you'd then stick LTO at the end of this stuff. Yeah, okay. I'm going to use the microphones.
Yeah, thank you.
Thank you.
I have an idea. And can't you, for starters, can't you drop the binary model interface and just have the same semantics, but use source files and in cost of rerunning the front end? Right,
yeah. So the question, the thing is, why do we need the binary model file? Why can't we just reread in the interface file itself and use that as our mechanism? Well, yes, in theory that would work, right? Because it's clearly got all the information that's in the binary module interface. But you don't want to do that because parsing is expensive, all this backtracking and whatnot. And so I think all the implementations that are being developed aren't taking that road for the reason that you also have, in GCC's case, in any case, you then actually end up having to suspend the current state of the parser and have a new parser object. And there was an experiment 5 years ago or so that Diego Novello and Danny Berlin, I believe, it was at Google were doing to try and make precompiled headers more composable. And that failed and one of the reasons it failed was I can't suspend the state of the parser in GCC because it's got too much global state. That was too difficult. And I remember I talked to Diego about this time last year, and his first question was, "Are you doing it like this? Because it won't work." No, I'm not doing it like that. Okay. Thank you.
And I have small question. Do you have the presentation you were talking about more in-depth presentation available somewhere?
Okay, yeah, it's the other presentation available. I presented, it was at the GCC Cauldron in Prague earlier this month. That first presentation didn't get recorded for reasons, but there is a presentation there that did get recorded where I'm talking about all the changes I did to the name lookup stuff. So that will give you more compiler internals than you might want, but that one is available. Okay.
Thank you.
Okay.
Hi. At the previous module talk, which was very good as well, I asked the question, I work at Bloomberg. How would you advise I incorporate modules in a code base that's 30 plus years old?
So this is the same. I was there, so I remember the question that you had, which was about, I've got 1 million lines of old code that was written by people who are now dead, and I can't change it because it's got business logic, I don't know, whatever. It's like, what do I do? Are modules a thing I can even use? The answer to your question is modules as it currently is written probably doesn't help you with your old code. But I'm not quite sure. But I know, I talked to Alistair at the committee and stuff, and he makes it. I understand the things going on there. I haven't quite got my head around what the right answer might be. So it's like, I think your question does not have an answer right yet.
Could I just give the concrete example? I have a code base. Let's say I even have a modern code base, just doesn't have modules. And so I have an infrastructure. Then I have a client that comes along and wants to use, and I'm giving as an example, date. I want to use my date class. So the client comes along and wants to use that and wants to create a module. So this is a new C++ 20, we'll say middleware.
Okay.
Now, I have somebody else who doesn't like fancy things or can't use it, so they create some more middleware using the date class. This is in the old style headers.
Okay.
Now, somebody wants to come along and use both of those libraries in one place. And you talked about the situation where you have both header files and modules, and do they mean the same thing when they come from both? And specifically, can we take advantage of the optimizations in the module when we have it, and when we don't have it, just go revert to the header?
Right.
That makes sense.
Okay, so that was a rephrasing of the question. I think what you've described is this picture here, but I might have missed something.
Possibly,
or
yes.
something fairly close to that,
Yes.
I would hope. And so the thing we're aiming for is that, yes, this will work. You could make your module date code, and then you could explicitly write a header file that's got extern declarations in it for the things that this exports. And then the user that doesn't want to use anything with modules would be able to include that.
But you said my module date, and I'm saying right now I don't have a module date.
Right,
I have an old one. So I have an old library that has a date. So date, date.h.
Yeah.
Then I have somebody comes along and wants to use date.h and produce a module interface. And
to that existing
existing library, because we have a lot of existing libraries.
Yes. I'm not entirely sure. Probably requires thinking about.
Fair enough.
Thing with these questions immediately get into things that are quite hard to fathom about. So yeah, happy to talk to you further, but maybe not right now. Yeah.
Is the export-import directive a commitment to someone else's interface, actually?
How
So if we write in one of your slides before this.
Yeah, okay. Let's find it. There we go. Was it this one?
Yeah.
Yeah.
So bar, if I write my own module
Yes.
and I write export import bar,
Yes.
don't I commit to the maintenance, long-term maintenance of the interface bar is exposing? And I'm not the author of bar. Why would I do that?
Okay, so the question is, have I just signed up for maintenance of bar at this point? Don't know, really. Yeah, I just write compilers. Yeah.
Okay, just give me this follow-up question of the same issue. I don't own and maintain bar, so now the vendor of bar sends out an update.
Yes.
What happens to my code?
Well,
Or someone using my module at this point
Right,
and with a
okay.
new version of bar?
So I've exported bar, export import bar, new bar happens. What do my users do? Well, okay, so the new version of bar should not break its binary interface, because that's just bad software engineering. If you've got a version 2, you make it backwards compatible. If it does break it, then it's going to be broken here.
It might change its overload sets.
That is correct. It might, if it changes its overload sets, it's changing its exported overload sets. Those are the ones that you see. If it changes its internal overload sets, don't care, because you don't see those. Yeah. If it's changing its interface, yeah, that will ripple through to users of foo. Yes, that's what you're saying here. One of the primary uses of re-exporting is conglomeration, sort of container modules that all they do is export a bunch of other stuff. And Bjarne in his keynote had examples of that, where he said import bundle starter and import bundle expert, and you'd get different sets of exciting C++y features that way. So all bundle starter would be export module bundle.starter, export import thing, export import the, export import the.
So if I understand correctly, if a new bar rolls out, I will have to rebuild my world that depends upon bar if I want to have a consistent worldview. If
you're using a new library, a new version of the library that you depend on, you have to recompile your code anyway. Yeah. That's not a new thing. Yeah. You phrased it in a way that sounded new, and I tried to rephrase it in a way that made it sound completely natural and what we already have to do anyway.
Yeah, okay.
I hope. Okay, are there any... Oh, yes.
So yeah, basically what we used header files for was to sometimes separate implementation from declaration, etc. Sometimes I want to implement forward declare a class, because I don't want people to start accessing, especially if it's old code. I want to just forward declare, and they have a header of functions. So if I forward declare a class and I just want them to use the pointer and the series of function.
Okay, yes. I didn't have an example of that, but because I just exported the whole class. You can export just the class name and then define and have the definition in the interface file that is not exported, and that definition is only visible to the module itself, and importers of the module just see the name as an incomplete type.
Exactly.
Which I think is what you described.
Yeah. And does it infer some sort of scope? Does the module infer, you'd have to use foo column?
No.
And it doesn't infer some sort of
the
scope.
module name is not a scope.
Okay.
Okay?
So you'd have to use to have scope. If you want to use scope, you have to use as namespace inside your module and export that.
If yes, you would have inside the module interface, you would put namespace my module in the way that we currently do for header files in exactly the same way.
Let's say STD.
Yeah, you can add stuff to it because it could be shared with other people. Namespaces are. We're going to, I think, about run out of time, but I think we're the last session, so okay. I think that's it. So thank you, everybody.